Welcome to day one of the CASE NCSEA SEI Joint Leadership Summer Series on Artificial Intelligence. Our first webinar will be presented by NCSEA titled Towards AI Adoption in the Structural Engineering Profession. Thank you for joining us. At any time, you may adjust your audio using any computer volume settings that you may have. On the bottom of your screen, you will see the Q&A pod. To send a question, click on the text box and type your text. When finished, click the send button or push enter. All questions that you submit will be addressed at the end of the presentation. We are joined today by our moderator, David O'Day. David is a structural engineer with over 30 years of experience in the design of complex buildings. He has particular expertise in the application of digital design technology in structural engineering. Based in Providence, Rhode Island, he leads the building structures practice for WSP in the USA. At this time, I will turn the floor over to David to introduce our presenters.
Thank you, and hello, everyone. Thank you for joining us today for this really exciting webinar series on the topic of artificial intelligence and structural engineering. We've got today a really great group of panelists that are going to present to you some of the findings and some information from the work that they've been doing as part of the inaugural grant of the NCSEA Foundation to study innovation in structural engineering, particularly in the area of AI. So I'm excited to introduce them to you. And I'm also excited that this webinar series will be a joint effort of our three professional societies, CASE, NCSEA, and SEI, over the summer. So you'll hear from some of our other associations later if you join us in the summer. All of our presenters today are members of the NCSEA Foundation's AI grant team, which is really leading the way in this effort. So really excited to hear from them. The panelists today are Dave Martin, who's an associate principal at Degenkolb. As a leader in adopting AI technology and advancing BIM integration at Degenkolb, Dave plays a key role in both project management and internal technology initiatives at the company. Welcome, Dave. Next, we have Andrew Sundell. He's a licensed architect and structural engineer. He started at HGA 10 years ago as a computational design specialist. Andrew now works as a structural engineer with a portion of his time devoted to research and innovation. And last but not least, Dr. Emre Toprak is an assistant vice president of structural engineering at WSP in the USA. Emre is specialized in the analysis, design, and evaluation of broad types of buildings and complex structures, and he currently focuses on tall buildings and their performance. Before I turn it over to Emre to start, I just want to tell everybody we're going to have some presentations by all the panelists. You can enter questions in the Q&A located at the bottom of your screen during the presentation if you like. To submit a question, type your question in the small text box at the bottom, and when finished, make sure you click the send button to push enter, and we'll probably answer some of those questions as the talks are going on, and then we'll ask the panelists after their presentations at the end of the three to address some of the questions. So with that, I'll turn things over to Emre to kick us off. Emre?
Thank you, David. Hi, everyone. I'm Emre Toprak from WSP, and I'm here with Dave and Andrew, and we are, as David introduced us, we are part of the NCSEA AI team, and we are excited to walk you through how AI is already starting to change our profession and how you and your firm can take practical steps to harness and lead. So before we start, we have some quick poll questions. Two of them is going to pop up in your screen, and about on your firm size and your level of experience. And as you answer, we will also scroll over the next slides as well. So let's start with the uncomfortable idea that AI is starting to change our profession. Not in some distant future, but it's happening now. And we start to observe in some real projects that in real workflows as well. The real challenge is, however, is how do we respond to that? And I want to stress that AI won't replace structural engineers. However, but structure engineers who use the AI will in time will replace who don't using it as well. As a signal that firms and individuals who learn to integrate AI through thoughtfully will be positioned in the firms and to offer new services to clients, take more design risks, and increase the capabilities and services and efficiency, and therefore lead the next generation of the engineering. So we are here today, aim to show you some of the tools, emerging innovations and strategies, and real examples that we observe happening around the world and in the country that can support your adoption journey. This isn't just about the automation, it's about augmentation and enhancing our profession. I think we have some results from the firm size and the years of experience. Probably you are also seeing the results also on the screen that we have mildly like crossover, like it's very evenly shared, distributed about the firm size we have, but mostly around the 36% between 11 to 100 size of employees. And we also have about the years of experience is evenly distributed as well. So that's a very good, broad, diverse audition we have today. So just to set the stage, I want to share why we are here today. In early 2024, NCSCA launched its annual Innovation in Structural Engineering grant and chose artificial intelligence as its very, very first topic, anticipating that and recognizing just how significant AI will be impactful for our profession. So the grant team is made up of 8 licensed engineers, with Jesse also recently joined to us, across the country, diversified in geography, and supported by an advisory panel of industry experts as well. We regularly meet together, and last year when we came together in San Francisco 2024 and to develop a practical strategic plan to help the firms all sizes and begin their AI journey as well. Since then, we delivered several webinars, presentations at the NCSCA Summit last year, and published and resources as well. So like the roadmap that you're currently seeing on your screen, I was going to comment on the next screen, that we will show you today, all designed to reduce barriers and support the thoughtful, risk-aware adoption. So at the heart of the work, the NCSCA's vision is embrace AI to empower the structural engineers to be leaders responsibly shaping the future. And we are proud of to chase this ambitious goal and offer some practical steps that we will be walking through in the session to help you taking those harness. So this is the roadmap, which with the QR code you can scan, and it also land you to our landing page in our NCSCA website. After defining the vision, we created this practical roadmap that any firm, large or small, can follow to start or accelerate their AI journey. So it's a 4-phase path, and starting with learn and strategize, implement and engage, grow and transform, and lastly disruption. So first and most importantly is learning and strategizing is the first phase. This is where currently we observe that we know that most of the firms are today. And I want to say this clearly that you are not behind. Just being here today and starting to explore the AI puts you on the path. This phase is about experimentation and exposure. Play with tools like GPTs and try Copilot inside the Microsoft 365. Experiment with the prompts. It's okay to break the things. The key is to shift from the knowledge and curiosity to structured learning. Firms at this stage should also consider that simple steps like setting up the sample AI policy, giving the safe access to small user groups in your firm, and capturing the lessons I learned. it's just not about jumping and straight into coding. It's all about understanding what's possible and changing the mindset. Secondly, so once there is some traction that you observe in your firm and interest, firms can move into the next phase, that's the implementation and engagement phase. So this is where pilot projects start, actually. And maybe that's the trying out commercial tool using a transcription like software for a project at meetings, that automating and repetitive of QA process. Maybe some of them is going to make a tangible impact, and some of them is not going to work very efficiently and speed. Give the teams the time, examples, and support. So as the adoption grows organically, when people feel confident, not just as proficient on that, this is the phase is actually that also where you start to track return of investment. So you can change your strategy as you evolve further. So you can set your goals and recognize what's working. And just for importantly, pivot if it is not. So AI is evolving so fast. So flexibility is very essential here. So the orange one, that's the third one, is at this point with the growth, you are aligning your AI strategy with your business strategy as well. So the firm knows what works and why, and then promotes it as well. But the next one, lastly, this disruption is where the firms go beyond efficiency. That's they begin to disrupt and start offering new services, improving design scope, and creating value for the clients any further as well. But remember, all the competitors, including the tech-forward startups, are also doing this. So as the landscape evolves, you also return back to your propositions and needs to be changed as well. So the biggest takeaway we found is that every firm can start somewhere. And you don't need to be a data team. All you just need is like a few curious engineers that with the right guardrails and mindset focused on continuous learning. But of all the tools out there, like large language models, like ChatGPT and Copilot and other GPTs, having the easiest entry point, that's the level one at the top, is that for the many firms. They are very powerful, flexible, and can immediately support with the workflows that is being used right. So next, Dave is going to take us deeper into the world of LLMs, and they really are, and how firms are using them today as well. And with that said, Dave, over to you.
Thanks, Emre. And I'm going to leave it here just for a moment. That QR code also takes you to like the full expanded roadmap, which has a lot more information on there, which doesn't work super well with PowerPoint slides. Too much information. And for the pilot projects, we've actually included quite a bit more in the webinar article itself. But we're going to focus today primarily on the large language models, RAG, which is using large language models to talk to your data, as well as coding. And why this subset of the discussion is primarily because this is where we are seeing people implement this at their firms too. Large language models is people's first foray into AI. RAG is starting to apply that to basically mine your knowledge base and all of the information that gets lost within your projects or within the mind of someone who retires, right? And perhaps the biggest impact we're seeing in firms of all sizes is using AI to code things, right? Because large language models are not good at math or engineering. They know what they've been trained on and not much else, but they can call functions using coding, like Wolfram Alpha or other types of platforms to do math, right? We're not really seeing a big mix of that, but people are using coding to great success to automate and or increase efficiency or options in their workflows. So one of the first messages we want to really convey, and we got to really get this out there, is hopefully firms are getting secure enterprise grade AI into the hands of your staff. There's an aha moment when someone starts to realize the power of this, starts to find out when models hallucinate, what they're good at, what they're not good at. But if people aren't using it securely, you're basically guaranteeing they're going to use free versions on the side, which could potentially be a bit of a security issue for your data paths. So I'm going to show a bunch of different options for this and sort of comment on costs and how this gets implemented and their strengths and weaknesses. But this would be our core first message here on this section is get this stuff into the hands of your people. All right. So one of the things is not to really judge the scaling of the GPT tech on the last model that you tried. If you tried something 6 months ago, it's been replaced by probably 10,000 models since then, including some of the flagship models from OpenAI as an example. But the Claude models and especially Google's new Gemini 2.5 models are state of the art, and sometimes a mix of these is the right solution. These models are getting extremely powerful. Hallucinations is very much still an issue, but something to consider. One of the first things that people will likely try is Microsoft Copilot. That's like one of the commonalities between almost all of our firms is that Copilot is here. It's $30 a month. It can connect your data. It can mine your team's messages in Outlook. It can find things that you might have missed in emails. And the good is that it does this all automatically. When you pay $30 a month, the data connectors and all of that pass are pretty much included. The bad is that you can't really choose your models. So you're going to be working with very basic models that are cheap to operate. And in our testing and talking to other partner firms, everybody's still a bit unhappy with Copilot. I asked it to basically help fix some fonts in this presentation, something that I would think would be very basic. And it says, no, I actually can't work on your presentation. I can only generate some ideas for you. So Copilot is probably going to be great in a year. But if you spend this throughout your org, just know that you're going to have severe limitations on what its technology is. One thing that we've rolled out at our firm is GPT for Teams for a subset of our engineers, primarily the ones that are working on coding. GPT Teams is a great option just to get people out there. It's pretty secure. There's some caveats. There's also an enterprise grade, which is double the cost. The biggest difference is the security layers. The nice thing about using like OpenAI or Claude or Gemini or even stuff from AWS is that you're going to be always getting the latest and greatest in features, but you'd kind of get stuck in someone's own model category. And unfortunately, there aren't a lot of good options that give you access to all of the models in a corporate enterprise setting without doing some custom development. But this Teams version is pretty good, and we'll talk about some of the security issues in just a moment. When you compare all of these up against each other, and I've kind of ordered them in terms of the security in kind of like, it's a little bit subjective. The top four are all pretty similar. One of the things to consider with some of the lesser options like GPT for Teams is great, but you don't have as much insight on what they can do in terms of accessing your data. If they have to engage a content abuse monitoring check on stuff that you've put in there, or one of your employees put in something that triggers something based on a keyword, they will not tell you that they're looking on your data. And there's also third parties that do auditing for the companies that can look at your data as well. I don't personally think this is a very big issue because there's so much volume of information going into these models. It's unlikely that a human has the time or the budget at these firms to actually do much with your information, but the third party auditing could potentially be a security risk. So, at our company, we're using these products, but we're not putting anything that rises under a confidential tag or under an NDA. And that's going to be a decision that everybody has to make for themselves in terms of what security they can stomach, as well as their corporate policies, as well as what they adopt for AI policies and their clients as well. Another kind of thing to think about when you're launching an AI strategy at your company is whether or not you're taking like an AI first strategy, or you also have a data issue as well. And I'm showing a platform here called Ignite, which we are starting to see adopted pretty rapidly throughout firms. As people move from a local P drive storage in a closet somewhere that's burning a bunch of electricity and has a lot of maintenance costs, we're looking into more cloud storage solutions that also enable AI. Now with Ignite, it's really a data first strategy. You need to move your data into the cloud, but you want to do it in a way that facilitates AI. And Ignite is kind of spendy compared to some of the other offerings.
So Dave, can you guide me like on which slide I need to sync in? So currently we have Microsoft 365 Copilot. Which slide I need to slide in?
got it. Yeah, you get a couple ahead.
I'm ahead. Okay,
Yeah,
I'll
I
circle back to
thought I
this
was
one. I think this
actually
is the one.
sharing. Keep going.
You are sharing, Dave. I'm seeing your screen.
Okay, excellent.
Yeah.
All right. But for Ignite, it's pretty expensive compared to something like Panzura or Azure Files, or just simply adopting something like Azure Blob Storage. But it connects to everything, right? It also has an AI co-pilot and agentic activities, so it's a very expandable platform. So if you do have a data first need, it's something really important to consider. But also, like, are you paying for AI twice now if you have Copilot and Ignite? Where's the overlap, right? This is a core decision people are going to have to make when they consider their data strategy and going forward. Another one that's really interesting, which we're seeing adopted in firms of all sizes, is a platform called Glean. Glean is an AI first strategy. It assumes you have data in the cloud somewhere and it can connect to it. But essentially, if you want to talk to all of your knowledge base documents, Glean can essentially automate this. And we've seen this demoed at some pretty large scales, and it works really, really well. An example with proposals, right? Half of the people on this call are 11 plus years of experience working with clients, doing proposals, writing, costing jobs. And what this type of agentic workflow is basically to go through RFPs for a business development strategy. But as you kind of intake documents, there's actions that you want AI to take on your behalf in sort of summarizing information or looking for specific criteria that are important to a client's data, or looking through your past projects to find similarities between what they're asking for and work that you've done. Glean can do this much, much better than Copilot. And I feel like this is kind of what Copilot aspires to be. But if you were to implement something like this, it's not cheap. Hey, just add another $50 a month per person to your indirect costs. Um, you know, what are you really getting? Does it meet your business strategy? Are you overlapping with something else, right? So, we presented like Copilot, which tries to do everything. Glean, which can be that first AI first strategy, or Ignite as a data first strategy. And you're going to have to evaluate these against what your technology needs are and how things are going forward to be successful. I think one of the key things, if you start to accept that development of tech might be in your best interest, is what if you enabled your IT staff or a consultant, if that's not within your skill set, to do some custom development. And I want to show you that it's not as hard as people think, though there are implications if you start to develop, mainly because you have to maintain your code and potentially scale it for a larger group of people. So one of our advisors, who's actually was a structural engineer, but is now more on the funding side of the equation, had said basically that they were to successfully launch and deploy a chatbot in 4 hours using the AI Foundry. And I found that this actually can be quite a bit faster if you keep it simple. So effort level 1 is basically launching something on the Azure AI Foundry, which you can host securely and authenticate using your Windows credentials. Now that may seem like kind of a basic step, but if you're doing custom stuff, authentication is huge because you got to make sure that only your people are able to use it, right? So that's some big advantage of sticking within the Microsoft ecosystem, though there's a lot of different options here. The only downside with these is that you're going to have a more basic level unless you adopt some of these templates. Now, this one was created for creative writing, but what it does is it takes source documents. It allows you to specifically address the research side of it, what type of products you should look at, or in this case, you could adapt it for a more structural engineering workflow, and actually give very specific tasks on assignment, right? So breaking them into multi-steps gives you better results. It's about $150 to run something like this on Azure, and maybe $5 to $10 a month assumed for token count. What we're actually seeing from our data is that the token usage is actually a lot lower than that, typically because this is meant for people that may not use AI at all, and you just want to get them out of a jam sometimes. Your power users may still want to use some out-of-the-box offering because they may need more power than this service can provide. At our firm, and I would call this level 3, we're deploying a custom chatbot to go alongside Copilot for some people and OpenAI's GPT for Teams for some people as well, right? Those folks who need the superpower, the best models, code interpreter, all of that, they can have it. But for everyone else, we want to make sure there's an option that gets them out of a jam. And this is a custom deployment on Azure using a GitHub repo called Azure Chat. The kicker is, though, is it's $400 just to maintain the service. Now, that includes a lot of costs and operations, right? It's fixed costs, but it's going to cost, some amount of money on top of that, right? So the break-even point for that is about, 15 people. If you have less than that, it's probably more economical to do something out of the box. It's very powerful, but there are going to be future maintenance costs using something like this. In terms of how it's launched, you need permission to basically interact with Azure AI, which is something your IT department probably only has if you haven't done this before. But in terms of basically cloning the GitHub repo or putting it on your machine, provisioning it on Azure is very straightforward. You have to do a couple authentication steps, which the user guide outlines very, very clearly. And then once you do that, you basically add your data sources and start architecting how you want your people to see a resource like this. It took me 3 hours to deploy it and have a beta, and then probably another 4 to 8 hours to do branding and basic additions. And then it was another 4 hours to create a model slider. So like when you go to the extensions feature, we have different types of extensions which connect to our data. We're still in beta, so we're testing different types of search routines, and we just don't have enough time to really dig into the mechanics of how that works. Suffice it to say that keyword search alone, as your data gets bigger, is not going to cut it. You're going to need some type of hybrid or vector-based search, which we're going to be publishing more information on our NCSEI website. But you can also offer personas, starting with a business writing prompt so that you get the right results and it doesn't sound like a salesman, which is typically what you'll get with AI. Prompt libraries as well. Andrew was kind enough to share this example from his firm with a more business development focused
Yeah, I mean, this is
approach.
just sort of the polished version of everything you've been talking about, Dave. And really,
Yeah.
we're not doing any engineering with this. It's built on our HGA branded language and responding to RFPs and proposals and that sort of thing.
Thanks, Andrew. And really the key here is that it's tailored around your business strategy. Now, getting back to coding, you could not really work on a repo this large without some pretty decent coding skills unless you have something where you're using AI within your development side. So this is Cursor, but there's many other things like Cursor. Claude Code is probably the best and most advanced right now. Can be kind of expensive. OpenAI has Codex built into their ChatGPT platform. But if you can work with these repos on a file level, you can trace through the entire way that this website is architected. And front ends are notoriously complex. So if you try something like this, you definitely want to use a coding platform. I just want to give you a couple quick examples on coding and engineering workflows because it's going to be really particular to your business, but I want to start off with a very small example because if you have something like Cursor, which I just showed, or Claude Code, which is even better, you can build some pretty incredible stuff. Even if you're a small firm, engaging one of your tinkerers to learn a little bit more about coding and start using these tools. So this was from one of our members who didn't have their less than 25 person firm, didn't have anyone at their firm could code, so they decided to go the consulting route. They found someone local with references from a local university who had Python and database experience. And what they were looking at was multi-step engineering problems where there was a lot of data handoffs in the middle. Excel was used as the anchor point because you can add coding processes to either bring data in or out as long as the data is in a specific format. They were successfully able to bring in ASC 7 hazard data, as well as wind and snow and seismic. There was also importing API data for USDA public soil maps so that they can initially get soil classification. Also integrations with code databases, as well as in some cases importing topographic information to see if they had slopes. This is all the type of intake information you'd need to decide if you are going to go the right direction for a project, right? And it was done for a specific type of engineering problem that was repeatable for this engineer, which could bring their 8 to 10 hours of lost information and handoffs down to approximately 1 to 2 hours. 2 to 3 hours of review comes down to 30 minutes. And the key for this example was higher quality and allowing people to expand offerings and respond more quickly, right? So this was done with consulting, but if you had like one grad level with Python experience, they could start to basically do this if they were given the time and some tools. At our firm, we're using AI more for software and optimization, designing structures and essentially connecting them through APIs, controlling eTabs through their API. We built a custom API for RISA for different types of projects, and this is paying dividends. We also used AI coding as well as traditional software engineering to build our custom interop platform. You could also use something like Speckle, but there's a pretty big knowledge. You need a lot of knowledge and practice to start using things like that effectively, and sometimes some custom interop routines that are very simple, tailored for your business needs, could really get you ahead as well. We're also extracting massive amounts of data from models and turning them into things that we can use in the analysis. This example in front of you is MEP distribution systems for a large building. And just some other examples before I turn it over to Emre. AI encoding is what you make of it, right? And the outcome is generally not AI. And I think that's the story for so much of what we see out there. It's called AI, but it's not really AI. But we're looking for impacts on our business. We're looking at things that we can do to really increase our exposure out to our clients and improve our offerings. So the AI is useful for whatever you make of it, right? So just wanted to kind of offer some of those examples that it's for small and large firms. And I'm going to turn it over to Emre to talk a little bit more about something that requires a little more involvement, but is also attainable. You just have to frame the right problems for machine learning. So Emre, do you want to take it back, or do you just want me to advance for you?
Yes, that would be great. Maybe I should take over. And thanks, Dave. That was great. Share. You need to unshare, perhaps?
Yep, go ahead.
And I hope that you can see the full screen
Yep,
again.
we can see it.
Wonderful. Well, now that we have seen how LLMs can enhance how we work with information and knowledge and communication. So let's talk about machine learning and how it can do for us as structural engineers. So at a basic level, machine learning is like teaching a computer using examples instead of like instructions. So instead of writing equations and codes line by line, we let the model learn from the examples. So the more relevant the data that we provide, the better the model can perform. But why does this matter for us as structural engineers? Because the machine learning may potentially let us capture engineering intuition at a scale. And we can use it for estimate quantities in early design and making decision-making in informed decision-making, automate classifying the checks and types, or even predict things that in longer-term deflections or other like non-trivial challenges, do it faster than ever before. So it's not about replacing the engineering, it's about enhancing it. You may think it as a machine learning as one of your core intelligence, side by side working with the computer in early stages of decision making, especially when there are too many variables or past projects are analyzed manually as well. And most importantly, you don't need to be a data scientist for this one. So all you need is just use machine learning, just to have some curious engineers in your team. And here, I want to put a cartoon about statistics, because it is actually that what computers works with. And in a way, I also prefer the name statistical learning over machine learning. And so how it works is that mainly using the regression models and its own different types of classification methods as well based on statistics. And it's been there for a long time, even the machine learning came before. So where does the machine learning fit in our roadmap then? So it typically fits between the second and third phases, as we earlier showed you in the roadmap. That's called implement and engage and growth and transform. So that means it usually comes after a firm has already dipped its toes into AI, typically through LLMs and ChatGPTs and GPTs and copilots. But here's the key. You don't need to have massive data sets or dedicated tech team to try machine learning. So many useful machine learning workflows can be built from either synthetic data that you create during your work, or you're from our own past projects if it's not viable as well. So even if that means a spreadsheet or a 40 or 50 samples might be like close enough to bring sense like meaningful, purposeful results as well, provided that you test with the benchmarking. So this is where small focused pilot projects make a big difference, and maybe predicting material quantities, or maybe it's classifying QA issues and prioritizing the RFIs, or machine learning gives you like a way to solve the problems that do not follow the clean rules. And as firms see value on the way, that those projects can evolve from pilots to our core capabilities and then services later on. So one of the most approachable ways to try machine learning in structural engineering which I suggest, is do it in the early design estimation. So think about how much time we spend during concept design, asking that how much will this slab need to be, and how much the concrete are we like talking about? Will this be at a PT or mild and reinforced, or maybe steel frame or timber? Now imagine that you have built a simple ML model that's trained on your past projects data, and maybe 30 or 40 projects summarizes with inputs that base size and loading types and floor height. You train the model once, and now every time that you start a new concept, you can circle back and can use quickly predicted quantities and that system types without reinventing the wheel again. So we have seen some examples happening in the globe that done in Excel, in Grasshopper, even in Google Colab. So it's very accessible to make the simple coding. And it doesn't have to be like perfect. It just has to give you an edge during early stage and decision making. And final decision needs to be still with the engineer, that the engineer has a responsibility to check the accuracy, whether if which regression model has been taken, or whether if the results are aligned with the cross checks and gives enough accuracy with benchmarking that you based on. And I want to stress that when we do the accuracy checks, it's also important to create a memo, perhaps. Where did you get the data set? Where is it based from? What are the boundaries? What are the limitations? So being transparent and traceability is very important. And then share as a disclaimer with the client when your deliveries, if it's a small side of the task that you're delivering as well. So how can actually get started with the machine learning in your firm today? So without needing a research lab or, like, let's say, 100,000 of data points is not needed. It starts with creating a data set. It can be either existing from your projects or synthetic. So quantity takeoffs or even your design calculation summarize. I want to stress that think about what is your non-trivial challenge. So what's your business about? If you're working on more, tall buildings, or where the wind is, or which is also very important than using historical data to create what the wind profile is something that you can create, because wind tunnel estimations may come in a later stage, but before that you may prefer doing the quick estimation of how the wind profile will look like from the past projects, given the stiffness of the building and its locations and environment as well. So there are some companies has tested quick studies after the training, quite a long amount of fluid dynamics studies as well. So this is one example. The key idea is that you don't need to build a product, or you just need a prototype that you need to test a hypothesis. Does this model help your estimator better? Does it better for flagging your issues and save time? Does it bring something like tangible in our business and in our deliveries? So when your team starts building and sharing these small wins, that's where your firm's culture is beginning to shift. So here showing some of the examples, like as I said, you shouldn't apply machine learning for straightforward things, like very specific, like you shouldn't do it like simply a deflection of a beam, for instance, but rather than deflection of a two-way slab long term is something like a non-trivial, for instance, but you can train it. And here I just want to show that you can also adopt machine learning libraries from a Grasshopper. That Launchbox ML is free to download. It's been developed by Nathan Miller and his team. That it comes with a good amount of libraries that you can test out the different regression models, and you can combine with your Grasshopper skills and doing some like basic level of machine learning prediction models, and share that files of Grasshopper within the team as well. They can use the train model, make the predictions further. This is another case that I've been involved before. That for the government project, that is a pilot project that they have the archetype buildings across the nation, that with school buildings, how they were aware of the risk of the seismicity, but they also have a certain amount of budget. They just don't know where to start. So it just helps at the very beginning with the tier 1 checks of ASE 41. That's how we can prioritize. Again, it's not the final decision making. It's an early stage that help prioritizing for the client, that where to start, which are the most critical ones in this case. This is the table on the bottom right is about the confusion matrix, which is called that you can compare the actual predictions between versus with hand calculations at how predictions and actuals align together. So we have on the way also learned that machine learning is not always smooth sailing. And first off, data. Most firms don't have their past projects neatly organized in a format that's ready to machine learning. It's a fact. It takes work to clean it, organize inputs and outputs, and sometimes you have to make the decisions like how to treat the missing values and normalize the different formats as well. Secondly, the problem is that definition matters more than the technology. And if your team isn't aligned with what the model should do or how success is measured, so even the code won't help. So there's other ways to approach that as well. And there's also a resistance in the firm, that cultural resistance is a fact. Some resistance, some engineers worry machine learning might replace a judgment, or that it is just a hype. So it is important to frame machine learning as a tool to augment, not to replace. And so the human still need to be in the function, that as an engineer that act as a rather than doing all intuitive tasks, but rather than an orchestra chief. So create more valuable time, use it for creativity and making more complex designs. That's how we gonna elevate our profession. So, and not just to be stressed that not every pilot works. So we have had models that didn't predict well, or problems that turn out to be better solved with a simple rule. So, but the wins are just as real. So once data is ready, we have seen meaningful insights in a day as well. So we have been able to test more designs and options now earlier, and in nearly every case that the teams, especially junior engineers, got engaged with energized in different ways as well, so they can just contagiously spread that knowledge within the firm. Just to wrap up, I want to leave you with 3 key messages about machine learning. First, it is real, and it's just not like a buzzword. It is already helping the structural engineers improve early design and check drawings faster and extract insight from the past work. Secondly, it doesn't replace the engineering, it just enhances it. So let's do it as what we do is best, and just test ideas, explore the options, and make informed decisions with more confidence and with speed. Thirdly, and lastly, that the engineers who start experimenting today are the ones that will eventually gonna shape how we're gonna work in tomorrow. So that doesn't mean that writing a perfect code. It just meaning that asking the good questions and timely questions, trying to do something that new, and bringing other along with you as well. So start small, stay curious, share what you learn. So that's how it's going to become real. Now I'm handing over to Andrew. He will show beautiful of things that what the tools we can use today nowadays as well. Over to Andrew. Do you want to take over, or should I unshare?
Great, thanks, Emery. I just took over. Hopefully you can see my screen.
Yes, wonderful.
Awesome. I will try to cruise through this as quickly as possible. We might be short on Q&A time at the end, but we're going to do our best to answer in the chat. As a starting place, I think it's an important concept to understand horizontal applications of AI and vertical applications of AI. Really, the ChatGPTs, Microsoft Copilot is really this horizontal applications where we're seeing clients, architecture and engineering, contractors kind of have this even playing field of using these really powerful tools in ways that help our process in many different ways. So really what I'm going to go through in this section is some of those vertical AI applications that start to get at very specific use cases for structural engineers that are not going through kind of all the weeds of custom development, and they're deploying their own solutions out there. With that, I think we're going to launch into a quick poll here, and I'm just going to keep talking while that poll comes up. The question being, what types of AI or ML tools are you currently using now? Listing those out, chatting with your documents, AI transcription, note-taking, or task management. Number 3, business development, client tracking, CRM. Number 4, quality review for BIM. 5, machine learning for early design predictions. 6, damage and crack detection. 7, data from documents. 8, enable engineering automation tasks. Or 9, material quantities estimating. Or none. Maybe you're not using any AI today. Again, these are the categories you can see in our Structured Magazine article, where we've pulled out what we're seeing kind of in our industry of how structural engineers are starting to use AI technology. So go ahead and submit your answer to that one. And it's if you've been tracking AI at all for the last year or so, you might have come across Stephen McCulloch. He's got this fantastic database of tools, and he's started these demo days that have been really powerful too, to give developers a chance to kind of showcase their tools. There's 1,671 AI tools in his database right now, and it's for all of AC, and it's pretty overwhelming, and a lot of it is some of it's vaporware and some of it's not, and there's different levels of alpha, beta development with those tools. So we're trying to pluck these tools that you can use today, or work with their team to try to implement something at your firm, and something that's really real and tangible to use. An interesting one recently, Governor Newsom launched a new AI tool to supercharge their approval of building permits, and this was coming after the LA fires. And ArchiStar is really interesting as a way to speed up the approval process, and kind of raises the question of, if AHJs are starting to use AI to approve our drawings, are we going to then have those same AI tools in-house to kind of do a pre-check so we can upload our drawings quicker without any issues when we actually submit it to cities? So ArchiStar is going to be one to look out for. There's a couple other examples that are doing that too. Cogram is sort of like your knowledge database for construction to CA activities, where it seems most powerful with site visits and capturing notes during CA. You can be out on site dictating observations and then creating site reports with that. They also have tools that do RFP responses and project bidding tools as well. A similar tool to that that's really focused on site visits that could be really valuable if you're a small or big firm. InspectMine is literally automated construction reports. You go out on site, you're talking to your phone, taking pictures of what you're seeing, and then it kind of takes that information and spits out a nicely formatted report from that information. I have to shout out for SEGPT. It's a great example of a knowledge transfer tool. So they've trained this model on all of the NCSEA technical documents, webinars, and all that. So it just makes it really handy to ask technical structural engineering questions that cites sources for your question, so you can actually find whatever article it may be citing. Similar, Clark was just launched like last week or in the past couple weeks by AISC. Very similar tool, but really focused on steel and documentation that AISC has. I gave it a question. What's interesting about this tool as we've been testing it? I asked it, what's the average steel tonnage for an office bay that's 30 foot by 30 foot? What I've noticed is that it comes back. The first thing that comes back is a new question or rephrasing your question in a way that it knows it's going to give you the correct answer, I guess. So instead of giving me this question, it kind of twisted it around and what is the comparison of steel waste between 25 by 25 and 30 by 30? And I was like, yes, that's good enough. And then it actually gave me a really long answer. You're not seeing most of it, but it's citing all these sources. And it's giving me, 4.1 PSF for 25 by 25 foot bay. And it is citing sources there. So you can maybe kind of go find where that's coming from and see if there's assumptions in there that are completely wrong for what you're trying to get out of it. So that's certainly an interesting tool. T2D2 is one we've talked about before. Automatic kind of using computer vision to do crack detection, site visit observations, deterioration, all that thing. Again, this has a really powerful report generation feature where if you need to deliver some sort of detailed report highlighting all the cracks that you're seeing, doing maybe takeoffs even, this tool has those capabilities, and you can sign up for a trial today and go test it out if you wanted to. Similarly, Aaron is doing kind of the same thing, but using drone footage. It's where you're flying drones. The example is a bridge here, and detecting all of the deteriorations and issues that are associated with this bridge. Trunk Tools is, again, another kind of CA database type tool. The example here is showing an automated way to go through submittals, and if it finds anything that is non-compliant or things you'd reject based on kind of your company's review process, it has kind of an automated way to do that one. So this is going to be an interesting tool to keep track of for the CA process. Stru AI is kind of a large language model for engineering calculations. It seems to me it's like if EnterCalc had a chat bot feature and you're kind of chatting with it on what you need the design to be. So this is marrying up some calculations with large language models to perform your calculations. Generate AI is specific for mass timber. So if you're really early on in a mass timber project and want to get some really high level kind of embodied carbon information, volume information, with possibly several different schemes, the team at Generate will work with you and help you through their tool to try to go through those iterations quickly, where you're inputting different geometry and constraints, and then at the output being kind of the comparison for early level conceptual level design of comparing different schemes for mass timber specifically. Genia is another one we've come across that's really interesting. They've trained a model based on a data set of architecture, residential floor plans paired with structural framing plans, and have built a tool now where you're uploading the floor plan of a house, and then it's trying to predict or give you a couple different layouts for framing or bracing plan. And the interesting thing they've done with their tool, even recently, they've been developing the calculation end of that, because as you can see, they're spitting out DCRs with floor joists. So there is some calculations happening within their tool as well, but it's also predicting and drawing that the structural plans that are associated with your floor plan that you're uploading. Augmenta is one we mentioned that's not structural specific right now, but they are kind of incrementally developing automation for all the engineering disciplines. They've started with electrical, and their current tool is within Revit. It's placing a piece of electrical equipment here, placing another piece of equipment here, and then it's um, automatically kind of finding the most ideal route for that. So they're continually developing their tool for the other engineering disciplines. Glyph is something you could try today too. It's a plugin for Revit by Chaos, and it's kind of like a co-pilot for Revit. It's a little bit limited right now at this phase in development, but you can see this is me running some really basic things like dimension the grids, and you see dimensions pop up and then tag walls, and it tags every unique wall that it sees. It starts to be kind of a mess, so you have to go through and adjust things, but it's kind of a nice first pass at uh, doing kind of large automated things within your Revit model. All right, gonna have to kind of wrap it up here. Build check here is another QA QC tool where you're uploading documents and it's flagging things for you to review. And then lastly, HiPAR is really a tool for architects right now. But the interesting thing is that they've already built, like a couple years ago, they built in some structural analysis tools. So it raises the provocative question of what if architects just have structural engineering built into the tools that they're using? What does our role become, and how do we plug into these different workflows? I went through them really fast, but if we on our Notion website, you can check out the list that we've pulled out and curated if you're interested in learning more about the ones you've seen today. And then we have some more on there that we obviously didn't have time to talk about.
Thank you, Andrew. If you want to just get those all up on the screen.
Yep.
I think the key thing to learn to kind of leave you with is that we as a committee are continually trying to look at what's really current, but also what's the most useful for us. There's information overload, and AI is not really applicable to so many things that we do, and it's often focused on the front end, early design, getting a first look at things, but it doesn't resolve the back end. We're not going anywhere anytime soon. But as Emery mentioned in the beginning, structural engineers who leverage AI are going to have a big competitive advantage. And I think we just need to recognize that and continue to work on that learning in developing a strategy so that you can start to implement and see where you're going to get your small wins, your big wins. And, let's fail fast at least so that we don't have to keep investing in something that doesn't pan out. So we'll continue to update the resources. We are going to post that Azure chatbot as an example along with the code base with all the modifications we've made. So that will be coming in the near future if you want to experiment with some of the Azure resources. And that we will wrap it up. David?
Well, thank you to all the panelists. This was really a wonderful discussion, and I'm sure a whirlwind overview for many of our attendees. And there have been many questions in the chat, so we've tried to answer as many of those as possible. We're on the hour, but I think we have time probably for one or two short questions. I'm going to start with one that I think is on a lot of people's mind, and it's from an anonymous attendee. So a lot of that in the AI world. And it's, can you train an AI model with data that is not yours? And I'll supplement that by just saying, I think there's a lot of interest. You talked a little bit about privacy, Emre, you as well, Dave, in your discussion of the different tools. What data is really required by these algorithms to be successful, and what are some of the issues surrounding that? You want to take that one,
Sure. Very
Emre?
quickly.
Yeah.
Yes, briefly. I think it's yes and no. If it's a publicly consumable data set, provide that you give the correct references, that's how you build up your training, and then give the results of how accurate your train model is. I think it's okay, but data is also intellectual property that if it's related to another client of another former project that you with your contract, how you defined, there might be some restrictions that you cannot carry over to your next project as well, but that ownership of the project may be related to the client as well. That we need to be careful about.
Yeah, I think contracts may be changing or adding more language into what can and cannot be done with data from clients and other partners. So that's certainly, it's a good reminder that we need to be kind of vigilant now of kind of reading the fine print of what your partners are saying about what you can and cannot do with their data.
Okay, I'm going to pick one more question, which I think is probably on the minds of a lot of the panelists as well, or a lot of the attendees as well. And that is, can you share an example of creating a basic AI agent for structural engineering workflow that is practical and feasible for a small firm? I think each of you spoke a little bit about how small firms might kind of take advantage of some of these tools, but can one of you
Yeah,
maybe give
I
a
can
good
take
example?
this one.
Dave?
Yeah, so one that I've been thinking about a lot, which I think would benefit small firms and large firms alike, and this especially relates to people who have tried Copilot, looking for an email, asking it to summarize your tasks. What did I miss from the last week when I was out of office? And if you do this, you'll find that it just has too much information to actually make good sense of that. So one of the agents that could be implemented in Copilot Studio is something that intakes your email and classifies it based on projects, right? So it looks for certain headings, certain content, certain people. And if it can classify to a project, now you know all of the emails and communication associated with that project. Taking it a step further would be classifying what's task associated within that email, and then basically creating tasks based on that. And if you can do that as a starting point, and then combine that agent at a daily or weekly interval, to basically do an analysis, you can basically help your most overloaded people with task and management and keeping track of assignments. A lot of software is starting to do this kind of automatically, and Copilot aspires to it. But this is something that could be done with not that many orchestration steps within something like Copilot Studio. You could do it custom, but it would just take a lot more development. I will just say, though, that orchestrating agents is kind of a frustrating activity. If you're serious about this and you see the value proposition, you might want to hire a consultant to help you with it. But those type of things are absolutely possible. Other workflows that I've seen for small business usually relate around like business development workflows, getting the right information to the right people, sending an RFP to like an email that triggers a chatbot that sends you back an analysis, stuff like that. But again, it has to really relate to what your firm is good at and what you need more help with. And for me, it's reducing the burden on your PM. So what do they need really, right? Work backwards from there.
And 2025 is like the year of the AI agents, right? And we're still like, I guess we're halfway through it, but we don't know what's coming in terms of the tools from Claude or OpenAI. I have an example in another presentation where Claude had developed a tool that takes over your computer. You prompt it just like ChatGPT or something, but you could say, build a spreadsheet for me. And it's taking screenshots of your desktop and understanding where to click to open a spreadsheet and can do a really simple spreadsheet. So all that to say is agentic AI, the conversation may change dramatically at the end of this year when you can actually have it running your machine, doing a specific task where you're just telling it what you want it to, how you want it to interface with your computer.
Well, thank you for those answers. And, I think like with many technologies, we hear a lot of hype. And what you guys have done is really show us the reality. You've shown us some actual examples that, attendees can dig into and they can use. And like many digital technologies, it may be not something that's like totally replacing a task or totally replacing a workflow, but working on small bits and pieces here and there that are really time consuming, and labor intensive, making you more efficient. So very interesting, and of course, going to be interesting to see where things go. And a great start to our summer series. I thank all of you for your presentations. I think we'll hand things back over to Catherine and wrap it up.
Thank you so much. Thank you, David, and to our presenters, Andrew, Dave, and Emery. We look forward to seeing you next month for our next installment with CASE, AI Strategy for Engineering Leaders, What You Need to Know. On behalf of CASE, NCSEA, and SEI, I'd like to thank you for your participation in today's event. This concludes today's program. Thank you, and have a great day.